I wanted to go over some more Python queries to show you, some more Python code to show you. Excuse me. And so you may have noticed that in your class docs repository, you may have noticed, if I can just get back there. How do I get back? I have so many windows open on my screen that it's just unreal. So I'm going to go to my terminal now, and let's just look at some of this code here. Hopefully you can see this up there. I wonder if I should make this a bit smaller so I'm not hogging the screen here. Maybe that'll be okay. Okay, so I'm in class docs, and if I go into, you can see my path where I'm actually in this is how I've organized my classes here. But I'm going to go into my lessons for today. And I go in there, you'll see that week 6 is already there. And week 6 is Python and SQL. And so we're beginning a new chapter here. When we come back from the exam, that means on Friday, we're going to go and to do more types of work with Python. Now, I've chosen Python for this class because I could have used Java, but I decided I'd use Python. In fact, I made this decision some time ago. And that is because many database management systems are actually written in Python. One of the database management systems that we're going to go over is something called Django. And Django is a web-based system, which means that you can create an instant website. And it has already built into its code the ability to manage SQL, MongoDB, or seemingly any database that you're interested in working with. And many industries actually use Django. And so that's going to come up on Friday, where I will take you through how to build a database, how to attach it to a website, and then how to use that website to access the database. And this will all be done through Python, which I think is absolutely extraordinary. I mean, it's I guess you have to be kind of like me to find these things absolutely amazing and riveting, but I really do find these things absolutely riveting. There's nothing in here that before I get into that, hopefully we'll have time at the end of the class here. But we have the practical that I gave you some time ago. That was, I think, last week. I wanted just to show you that, I wanted to just give you the answers. Now, there are many, before I get to the Python here, there were some other queries that many of you found that did exactly the same job. And that's fine, as long as your query gives the result, which is why, for instance, I gave you the correct output here. And so if your query gave the correct output, then that was correct. But otherwise, this is the query that I had in mind. You'll see that in each case, I have the same questions that you had for your practical, but I'm just giving you the query that I had in mind. But that doesn't mean that you were wrong if your query was similar. I think that these grades are posted on. I think they're posted. You'll have to, well, I'll have to check on that. If they're not, then they will be soon. But still, I think that I think for many people though, the grades are fine. Not to worry. So please do take some time to go through these things. If there's time in the end of class here, then I'll try and go through some of these and just kind of give you some ideas about how they work. But I want to just actually get out of this for just a moment and go into the actual source code for Python. Now, you probably noticed now that there's two old ones, the two old pieces of code we had from last Friday, Simple Query 1 and Simple Query 2. I've copied them over so that everything is just in the same place. I thought that maybe that would be a good idea just to have everything there so that if you're looking for these things, they're just all there. So there is a lot of repetition in our class docs, and I hope that that mess doesn't bother you. But I think though that if you just look at if you look at your class docs in terms of what did we do this week, then this week, week 6, we covered these queries and we also covered these insertion pieces of code in Python. Anyway, so you have an idea about what was actually covered each week, and so that's really why there's this repetition. Now, let me just go ahead and show you that we do have the old database that we've had before using SQLite. And in fact, we have a builder in here, which is, again, the same thing that we used last week. I like this builder because it has all the files in there. It has all the data in there, and so it's very easy to build a builder file just by doing this. And you have your keys and your other things are all included in the table creation. So it is a perfectly good database that you can use, not just in this course, but perhaps if you're doing a senior thesis or something else and you need a database, you can always go back to this and use it as some kind of reference. And it works out quite well. So I've created a database already, which you'll see is this my database. And if you go ahead and run Let me just go ahead and run the code from last time here, just to give us an idea about what it was. Actually, not, it's not this. I think I should be able to run this thing just by this. Simple query 1. Now, what this is doing is this is actually going through and using Python to connect with your database. That is where this information here comes from. Let me just go back and show that information before we go any further. So if I go into Vim, I'll just use Vim here to show you. Simple query 1. Then just to make the same point that we did last Friday, that is that what we do is you have to define your table and your attributes. If you're using multiple tables, then again, you have to define those tables too. But you'll notice that these are all just strings. There's nothing different about them. They're just strings, but these strings actually are attributes which exist inside the instructor table of your database. So this is my first print statement that I'm saying, I'm running a query and I'm showing you what table I'm going after. And don't forget that you have to put this F in here. This is the only class, I think, in the world where you want to get an F. The only class where you want to get an F, but this F right here means to format everything so that, for instance, when you go ahead and submit your string, or you can concatenate this this my table string, which is this word right here. You can actually place or superimpose this instructor word right here, and notice it goes between these curly brackets. Now, the reason why I'm making such a fuss about this whole thing is because when we get into Django, it's just this. We have to know this kind of notation. This syntax is actually very important. But I think though that while it looks ugly and like line noise when we first see it, after you've been looking at it for some time, it kind of just makes sense. You just have to accept that that's what the format is going to look like. This over here, these pieces mean actually to impose a quote. That's actually kind of interesting. In fact, one thing that's actually quite nice about this is that if I copy this information, let me show you this. I'll copy this right now. I'm going to get out of this. I'm going to go into a brand new Python. Whoops. And then if I paste this in there, you can see that this statement, I've just pasted everything in here. That means that all my attributes, attribute 1, 2, and 3 with these strings attached have all been submitted into Python. And so my print statement is actually the piece that's where this thing comes from here. But notice though that a print statement that comes with quotes, and those quotes are possible from this. And so we need that string, we need those quotes, because when we are connecting Python to SQL via the SQL3 library that we import, we need to use quotes. In other words, for instance, if we're looking for a specific name or we're looking for a specific string of some sort that exists in the table, then our SQL query is going to require these quotes. And so now we have a very powerful tool in our hands, and that is that we are able now to actually inject quote characters into our string. Because otherwise, if we didn't have these slashes here and here, what would happen? In fact, if I just go back here and remove those, let's just remove these and see whether we can just put these quotes in. It'll give us some kind of an error because it's saying Python sees this as one string. That's one part of the string. But then there's this extra built-in stuff over here, and it says, what is this? I'm confused. I don't understand what I'm supposed to do with that. You're not concatenating strings in the way that I'm used to. I'm just confused. I'm going home to bed. That's what Python is thinking. But actually, though, if you put these slashes right here, that means that you're just imposing these quote characters, and they're just characters. They're not changing the text in any way. They're just adding to these characters to the text. And so that's why these quotes are able to come in. Let me just show you something else. So if I just type in a print and I put my table string here, you'll notice that there's no quotes there. And so if I actually superimpose these quotes, then how would I do that? I could put a slash quotes. I mean, you have to do something simple like this, which would just be insane. I think this is another way of doing. I think that would do it. There we go. So you can, there's other ways, and I mean, I know this now looks more messy than ever. And so I think though that if you just go back to using the system that we had before, where you kind of build your query in text, and then you just remember that these are where the quotes are going to go. And you remember that your actual variable string, the string is going to go right there between the curly brackets. I think that might be easier to stomach. At least it is for me. Okay, so I'm going to get out of this, and then I'm going to go back to the code that we were looking at before, which was simple query 1. And so one thing I should probably take you through, which I didn't make a very big point about on Friday, and that is that when you are working with Python with your database, you must import some kind of library. And that is because Python doesn't know how to deal with SQL unless it has a library to take it through, to actually have it to connect to the database. And so that's what this is over here. This import statement is to get some extra code on board, to load a library, which is going to assist it in actually connecting to the database. So once that library is in, by the way, this library you do not have to install. I believe that every time you install Python, it just comes as a part of the code that you get. There are some libraries that just come with Python without having to, you don't have to install anything extra, and they just work right out of the box. However, there are other kinds of libraries, for instance, like more statistical ones, or maybe ones that are more, I don't know, more built for analysis or something. Those ones don't come standard, and so you have to install those yourself. And that's, you'd use pip for that, but never mind that for now. Next, we're going to be talking about, we have to assign another string here. So this string is going to be called the file name, the DB file name string. And this string is going to be assigned to this string here, which is the name of the database. That's just a file name. It's nothing else. It's just a file name. But actually, though, in terms of the code, it's just a string. And it happens to be that this string is the name of the file that is the SQLite3 database. So you need to tell SQLite3, the library, who we're connecting to here. What database is it that we're going after? Now, in this case, I'm hard coding everything, and you probably think that that's, if you're a die-hard coder, you probably think that it's never a good idea to hard code things like this, like hard code file names, because the file names could change, and then you may find that you have to go back into the code and change things. And so it's just for the point of for the example, I'm just putting in the file name here. But in the future, though, you might have some kind of a system. If you're making this as a bigger database system that more people would use, you might have some kind of a way of the user typing in or selecting the file name so that it's not hard coded in this system here. But here it is. Next, I have this con over here, and that stands for connection. This is a variable, and that variable points to this this piece over here. And what this piece is doing, it just says, okay, make the connection between you actually load or open the database, load the contents, put everything into memory, and then get everything ready so that we can start typing in some queries and getting some information out of this database. So that's a lot of things going on, but because we have this library, which connects the database, that, it opens the database, it connects to it, it establishes a connection so that we can work with it. This is really all we have to type in. And that's really the beauty of these libraries, and that if we did not have a library like this, we would have to type in this code ourselves to make this handshake happen. But as it is, the library exists, the handshake happens for us just with this line of code, and everything's wonderful. Up next, we have these, again, these variables, which are just pieces of information about the actual query that we're putting together. So here's my table. Here's my first attribute, second and third salary. This isn't the best way of doing it because if you just look at the attribute 1, attribute 2, attribute 3, you don't really learn much about what those string or what that string could be. So you might, I mean, I didn't for this example here, but when you're working on bigger code, you might consider changing this name to be like the name attribute, or the department name attribute, or the salary attribute, something like that. I did that for today's code that I wanted to show you that actually does that changes the database, and so it helps to make the writing code more simple. So then next, what we're doing is we're putting together this query statement. Now this is exactly everything that we just discussed when I just went into Python just a little while ago, where I'm superimposing these pieces of information or those strings into a larger string where I have, for instance, attribute 1, attribute 2, and attribute 3 from this table here, where, and then I have another, and then I go back to that attribute again, where this attribute is, and then this is just all standard SQL stuff. But what I'm trying to say, though, is that when you're putting together attributes and strings and queries in Python, you can simply create any kind of query or any kind of database command that you want just by putting pieces of text together, kind of like working with Lego. You just snap things together, and then once you're finished, once the string has been completed, then you should be able to just to submit that string to your database. And how do I submit this to my database? Well, again, I have to go to the connection. After all, this con here is Python's way of saying, I represent the connection now. Let's go back up here again. You see up here where I said over here, con is equal to this. That means now that anything that has to deal with a connection to the database has to be, you have to use con dot and then that command, because con represents the whole database connection. And so going back down here where I have con dot execute, what that says is, execute is a built-in command here, but it says here, okay, use the bridge or the handshake to the database that we've established, and then run this command here, which means to basically push this string, which we created, this is our string up here, this whole string up here, but push this whole string into the database and see what the database does, see what the database says. The result of that is going to be then returned to Python and stored in this variable here called result. Now, one of the difficult things about result is that it's just a bunch of binary. I don't think you'll be able to see anything that's actually very helpful until you do this other command here called fetch all. And fetch all, you have to basically say here result. You're saying, result is going to be filled up with stuff. You're going to say take all that stuff and dump it on the door of fetch all and say, hey, fetch all, or to go through and fetch everything that there is inside this result. Please go through this result, parse everything out for me, and then allow me to put everything into a human readable form so that I can see what my results were in the database. And so that's what this is all about here. This is what they call a parsing stage, where I'm going through this result and I'm going through the information and I'm putting everything into a kind of a human readable form. And that I'm going to be assigning to the human readable form, I'm going to be assigning to the variable called tables. And then to actually get any useful information out of tables, I think that you have to do something like this. You have to actually iterate through everything. And so that's why, for instance, when you run this, you get your row coming out. And that's because you're iterating through this parsed result that has come out of your database. And that's what this is. And again, I'm working with, this is a for loop for my index, or I, in tables. Tables is going to be a kind of a, I don't know if it's a list, it's going to be similar to a list. And what it's going to do is it's going to pull out, this is Python. It's going to go through the tables here and it's going to pull out row by row by row and then superimpose that value or save that value as I. And then it's going to, then when I have a string here that's going to be printing, it's going to be putting that whatever I has been saved to for that particular iteration, it'll print that to the screen. And don't forget there's this F there to make this possible. I could have used anything here. I could have used for Bugs Bunny in tables, then printf f tab Bugs Bunny. I could have done that, but I use I tend to use I because it makes things more easy to read, but also I stands for your index. So for the index and tables. Now, one of the big things that I would like to stress is that you want to have this, once we have finished working with the database, we're done with it. No, there's no more action to happen here. We don't need to do any more queries. That's the end of our code. The code will then close out the database connection. That means to release the database or that memory that's holding on to that database. If you're working with a very big database, the whole database is going to be loaded into memory. It's just picked up and then dumped into memory. Whether that means a swap file, or whether it's actually in RAM, It's up to your operating system, but it's taking the database and supporting it in memory in some way. And so when you type in connection close, that means to unload all that memory that was holding the database. And while the databases are small, you probably won't notice any difference in your computer. But if you run this thing hundreds and hundreds of times and you never close your database, then that means that your memory may actually fill up with this database and you could be prone for system crashes. In the old days when computers were actually very, had very limited memory, it was absolutely essential to close down the database seemingly between uses or between queries, because otherwise you wouldn't have enough memory to do basic work like printing or to work with files or anything. And so some of the old database code, you'll notice, opens and then closes. It opens the database, runs the query, then closes it immediately, and then it does that. But we don't need to worry about that anymore. Just make sure that you do close the database once you've finished it. And I hope that I remember to do that. If I don't remember to do that, then that just means that the database hangs around in my memory for a while until my machine either resets or reboots. Are there any questions over that code? I think that what I'm about to show you now is basically the same thing where I have changed my strings. Actually, the other one, you might want to, I have added some color to this just to make things cool. If you run this, this helps you to kind of see what's going on, what has to happen when you're running a database. So this is a print statement that just says I'm running the table in course. Then we have over here, this is the actual command, the string that I've just put together. That's actually making this. And that means that's actually where I'm getting this information. But I should be able to actually select this piece of code here and get the exact same information out of my database. And so this is when I'm working with code. I tend to put things in color like this because it helps me to see the parts of the program that are making things happen. Now, when you look at the code, it's not always as easy to see the color because the code itself doesn't always come through in color, unless of course you set up your editor so that you get color coming out of it. But I'll just show you what this looks like here. If I go to simple query 2, which does exactly the same thing as simple query 1, except query 2 does I think 2 more queries. I'll just take you through this and show you what this is here, but I'm really defining the colors that I'm going to be using for my print statements. If you're interested, you can spend some time looking at that. But really, though, to put color into your print statement, all you need to do is have this BI green plus, and then you have your string in the middle here, which you'll see right there. And then you want to have this plus white here, and that means reset the color back to what it was before. And so that's where this comes from here. And so you can spend some time playing with that if you'd like. These are what the codes look like. You'll notice again that, for instance, we have this slash. When I said that earlier, like for instance, when you have to use a slash to get your quotes to show up, this slash is what makes these characters possible. So this is actually becoming a kind of a character that creates color. And so if I put this color in front of a string, then the color from that character then rubs off on the string, and so the string is then that color. So for instance here, where I'm actually establishing my connection, I have bright cyan, which is the color character. Don't forget that I need, again, every time I'm running my code here, I'm superimposing something into my string using these curly brackets or these curly braces. I have to have this F to make that possible. Now I'm saying this F thing again and again because in the past, students of this course have been working. In fact, one person came to me and she said that she had not slept in about 24 hours because she couldn't get her statements to come together. She couldn't superimpose one thing into the other, and she just was becoming just delirious. And so I looked at her code, and it was just because these Fs had not been put there. It's very difficult to know that. It's not very easy to find this online, but just remember that when you're superimposing one string into another, if you have this F, then that means that this is not possible. Otherwise, it doesn't work. Okay, so my first query then, you can just get an idea about how I just have some print statements where I'm just putting in some color. And then down here, for instance, I'm using bright yellow plus, and then again, there's this F, and I'm superimposing my index, and then I'm showing the results. So that may help you if you wrote your code, if you're playing around with code, or playing around with Python code to make a database. If you use color, that means if I'm looking to see that, you know, I'm running a, let's see, I'm running my query table here. If I can just remember that green represents all my queries, sometimes it helps you to study these things, or just kind of like get to write your code. So anyway, I always think it's kind of fun though to write this in sort of write in color here. So then I can just look at my color and say, okay, green is giving me an idea about what it's doing, and the actual cyan color that I'm using here, any code that I see that's in cyan, or that I actually wrote to be in cyan, that's going to be my actual string that I'm using to actually to do my my query work. And then everything else is just the results. And so this may help. If it doesn't help, then forget it. Don't worry about it. You don't have to have color in these things. But the next one is simple querying. If we have queries, then I have a simple insert too. And so let me just run this simple insert here. Oops, not that. Simple insert. Again, I have color for those of you who are interested in looking at color, but otherwise I have it just regular, in this case, blue and white. What this is doing is, I should have actually opened something up first. Let me just show you my database. SQL3, my campus. Oops. I've just created a new table here called study music. In fact, I'll show you, the table actually does show up. Study. Oops. Okay. Now if I type in .table here, you'll see that table is gone. I'm going to get out of this thing here. I'm going to run my special handy dandy code here. I'll take you through the code and show you how it works in just a moment. And you'll see now that I've not only built the table using this command here. This is my table creation code, where I have an ID, I have a favorite song. Everything's in bar chart just because I'm lazy. And then I have the band name. I've actually populated that table here. So let's just go back into my database, and you'll see that if I type in table, there it is again, right there. And the schema is this. It's exactly the code that I wrote in Python. You can see that here in Python, and you can see it down here in my create table code right down here. So that's very good. So let's go through the code and just see how that works. How do I build tables using Python? You might need this, by the way, if you're building tables, because I used this when I was writing a program. I decided that when people were using my program, sometimes they had comments that they wanted to write into my code here, or they had comments they wanted me to take into account when they, to fix my code in some ways here. This is before I was using. Let me just get this thing done here. Stop talking again. But this is before I was using GitHub to do some of this work here. I was using Bitbucket, which didn't have the same kind of issue tracker. And so anyway, I created if anyone had any kind of information or feedback in one of the programs that I wrote, then they could write that feedback in the program directly. And then I made a table that would actually hold their work. And then I could just use that in one of my other programs to kind of get the information out. But that's how I stored their comments. So you can always use that you can always like create a table on the fly if you need to store some kind of I don't know, backup information or something. So anyway, let me just let me get back to this. Okay, so again, we are loading the library for SQLite 3. Again, I'm telling it what the database is that I'm working with. And this is actually kind of interesting though, because I mean, remember that now that I have a connection to the database, as I have right here, it's not just about reading the database, but I could actually write code that would alter the database. And so it's for this reason that you have, ultimately for this reason that you have these builder files, because not every time you run Python files is it going to go smoothly. In fact, you might have a piece of code in there which somehow corrupts, for some strange reason, corrupts your database. And if that is to happen, then don't worry, because you have the builder file so you can recreate this whole thing here. So don't worry about corrupting your database. As long as you have your builder file, you can recreate the database and you'll be fine. Okay, so let's go through and see what the code actually is doing here. We have the simple table creation. This is just I just put this up here so that you can see what's supposed to happen. It just helps me with writing the code. But for instance, again, I'm creating my table string. So this is going to be called a study music table, which is brand new. This table doesn't exist. I have my first attribute, and I'm just calling them attributes because I'm not really sure what else I should call them. But this is actually the whole line of text that I would use to define this ID, integer, not null. If I wanted to have this as a primary, I could always put primary key in there too, or I can put whatever other constraints I want to use. But that whole line goes here, whatever we would use in our table creation for this ID attribute. Then I have my second attribute called favorite song. And I use varchar just because I'm lazy, but I guess I could have used blob or I could have used text or something that might have made this database a little bit more efficient, but I didn't. That's going to go here. Again, it's just the attribute with its variable type. And then down here for variable 3, or attribute 3, I have band name and varchar. And then down here, I'm actually putting those, I'm superimposing those strings into my bigger string, which really becomes my table creation string. And that's what I call over here, my creation underscore str. And so you'll see that I'm typing everything in uppercase here, just so it's easier to read, but it doesn't have to be. But your command is exactly the same one that we've always seen. So it's create table, and then over here, I'm going to superimpose my table str. Well, what is that? That is this variable here, which is correlating to, or which then is which correlates to that study music here. So in other words, this final string is going to be create table study music. And then inside there is, and I mean, remember how what the command is that actually creates tables, and then you have to say once you've told or given the table name, then you have these parentheses, and inside the parentheses you have to say, okay, the first thing is the ID. It's an integer. It's not null. It's a primary key. And the second thing I have is my favorite song. This is varchar. And then the third thing I have is my band name varchar. All that stuff is being superimposed here. That's this attribute 1 over here is this line of code right here. And so I am building my code in this way. I'm just building a command by putting pieces together. Now, let me just stop for a second here and go back and talk about something. Why am I even bothering with these attributes? Why don't I just why bother superimposing anything? Why not just throw this stuff directly into this create table command here? Is that really what I want to do? Does anyone have any ideas on why I choose not to do that? Anybody in here? Yes, so the question is, why am I using these strings? Why am I superimposing smaller strings into a bigger string? Why do I not just write one giant string where I'm not superimposing anything? I'm just saying, instead of putting this, I just have this as a string in here and forget any substitution at all. So I can, yes, that's right. So I'm getting some, so in here, one of the suggestions is that we can accommodate for different types of values. Yes, if you want to change elements, you'll need to redo the migration. That's correct, Alex. Bravo, bien fait. And then will it override anything here? A larger string seems like it would be prone to more errors. Rachel, that's a very good point. It may not be more errors, but it's more complicated. It's much more complicated to control. So you do have so your point there, Rachel, would a longer string make things worse? In some ways it might, because it's more complicated to manage. But actually though, what I'd like to say though is that I'm going to reuse this same string, the same creation statements again and again and again. And each time I create a new table, I'm just going to change this stuff up here. So in other words, I can put this, although this isn't in a function here in Python, but if I wanted to, I could put this into a function. And then the function would have these parameters of the attributes and the table name. And then it just knows, it just knows to do the same thing every time it gets these attributes, and that is that it creates a table with 3 attributes. And so I would return this string each time I call this function. And so you want to do something like this, though, so that it becomes easier to perhaps reuse the code again and again and again. So I haven't put this together in here, but you'll notice that in some programs that actually work with databases, this is a function, and these are the inputs to the function. And you just send those inputs to the function. And then when those inputs arrive in the function takes the first input, which is this, and makes this table. Then the second input, which is this, and then the third input, which is this, and the fourth, and so on and so forth, to create the table. And then it just returns a string that you execute, and your table is made. And so if you do something like that, it makes things much more simple. And so while I didn't create a function in this thing here, because this isn't necessarily a Python course where we have to know a whole bunch of Python, but if you're interested in like writing code that might help you do this more quickly, then perhaps this is something you could look into. You could write your code so that these were all actual functions. The next thing here is I have this try statement here. Now what I'm going to try and do is I'm going to try and create my table. This is my string here that creates the table, and I have this try, and that means try Python, please try running this command here. If it crashes and doesn't work, then don't panic. We'll just move on to the next part of the code. That's what this is saying here. So it's like I'm going to try and create this table, but if the table doesn't work for some reason, like maybe the database is write protected, or the table already exists, or something terrible happens where we're just unable to, and we don't really know why, but we're unable to create that table, then it's no big deal. The program doesn't crash. We just realize now that there's some kind of an error. And so I'm assuming that the table already exists. But also the table, if you couldn't save to the table, then maybe you'd have the same problem here too. So anyway, you have to catch your exceptions in some cases, otherwise your program will crash. Next, I have this query up here that just says, I've already defined what my table is. This is my query that's going to say, just run through and see what's actually in the table. And so I'm going to, in fact, I don't think I actually ran that thing here, but I guess I could have done. The next thing I have, for instance, is I'm going to be actually adding some information to this. And so this is my insert statement, which is exactly the same way. I'm just going to be putting up saying, now I'm going to be inserting some information. And again, we recognize this insert into, then we have the name of the table, and then we have the values. And the value is going to be inside this parentheses. Now, this is where I have to worry about putting these quotes in here, because I'm going to be putting in a song, which is called MC Solar La Vie Belle. And it's you can check it online, it's quite not bad. It's good dancing. It's good to dance to. But I'm changing my attributes so that the names are a little bit more readable, more understandable, and more, it helps me to write my code. All I know is that this variable here is the ID, this is the song, and this is the artist. And then when I superimpose these things into this string here, it helps me to see what's going to happen. And then it creates a string, which then when I execute that string, which is my insert, and then it basically writes that data into my database. But one thing I need to do is I need to save each time I make a change to my database. I need to tell the database that this is for real. I want the change to stay. And so I have to use this commit command here, which means go back to the connection and commit. We've used this all the time when we're working with GitHub. I think I'm drastically over time here. I have 2 minutes here. I didn't need to keep you for so long here. The rest you know already. This is just the same old stuff. I'm just doing a verification that actually things did work. I'm just querying my table again to see that everything did work, and then I have to close my database. That is that. I didn't mean to keep you guys for an extra 2 minutes. I do apologize. I do tend to get carried away with this stuff. But if you have any questions about any of this stuff here, please let me know. You can always send me a Slack message or whatever it is. Like I said, on Wednesday, there's no new material, but I will be near my computer, not in class. You don't have to come to class, but I'll be near my computer at home. And I will be able to see any questions that may come through on Slack, and I'll be available to answer any questions there. And between now and then, also on Slack. Alrighty, everybody, any questions? Stay well. I will see you all very, very soon. Happy Monday. By the way, Monday is Allegheny College's new Friday, am I right?